Okay, let's talk about non-differentiability. Now, if you remember last chapter when we did limits, we talked about you can't do the limit if the function isn't continuous. Well, you can't take the derivative if the function is non-differentiable. These are the cases when a derivative doesn't exist. So these are the 5 things that we look for, and if any of these things happen, then it's not differentiable. Now you'll notice these 3 should look familiar. These were the 3 we talked about when we talked about continuity. Yeah, I spelled that right. So when we talk about derivatives, we say a function needs to be continuous and differentiable. So these are the 5 things I look for. If I have any of these 5 things, I cannot take the derivative. It doesn't work. So let's do some examples. We want to find the x values where f of x is not differentiable. Well, if I look at number 8, let's think of imagining the graph first. This is an absolute value, so it looks like that. So let's go through our 5. Do I have any holes in number 8? Nope, no holes. Do I have any jumps? Nope, no jumps. Do I have any vertical asymptotes? Nope, no asymptotes. Do I have any sharp turns? Yes. This right here is a sharp turn. So it says find the x values where f of x is not differentiable. We would say x equals 0 because it is a sharp turn. Now let's look at this one. So if I think about this, I have x squared when it's less than or equal to 0. So that's going to be like that with that. And then I have x at x greater than 0. So straight line like that. So if I look at this one, go through our 5 again. Do I have any holes? Nope, no holes because it fills it perfectly right there. Do I have any jumps? Nope, they meet up perfectly. I don't need to worry about jumps. Do I have any vertical asymptotes? Nope, don't need to worry about vertical asymptotes. Do I have any sharp turns? Yes. Once again, right there, that's a sharp turn. It goes from one smooth line to one sharp turn line. So we would say this one is also not differentiable at x equals 0 because it has a sharp turn. Okay, now let's try number 10. So let's look at the graph. X squared when x is less than 0, so that's our parabola. Has a filled in circle. And then x squared plus 1. That plus 1 is going to be a vertical translation. It's going to move it up 1. Like that. So it's going to look something like that. Now we go through our list. Are there any holes? No holes. Are there any jumps? Yes. So I'm going to say x equals 0 because it has a jump. Now we can finish it out. No vertical asymptotes, no sharp turns, and no vertical tangent lines. Or if you went to draw the slope, it would be a vertical line. That's what a vertical tangent line is. So that one's good. Now let's do number 11. So if I think about this one, first off, I have an x on top and an x on bottom. That simplifies. So that means right away, I'm going to have a hole at 0. I also know I'm going to have an asymptote at 1. Now, we don't really need to graph it all the way because I've already gone through my list. Any holes? Yes. I have a hole at x equals 0. Any jumps? No jumps. Any vertical asymptotes? Yes. At x equals 1. Any sharp turns? This is going to be a rational function, so it's all going to be smooth curves. And any vertical tangent lines? We shouldn't have any on this one. Now let's look at this one. Cube root of x. This is one you should have memorized. It's going to look like that. So if I think about this one, go through my 5. Do I have any holes in this? No. Do I have any jumps? No. Do I have any vertical asymptotes? No. Do I have any sharp turns? No, it's all smooth. However, if I were to draw a slope line right there, it would be vertical. So at x equals 0, that one's not going to work. Now, another way that you can see this is if I take the derivative. So I'm going to write f of x in exponent form, 1/3. And if I take the derivative, the 1/3 goes out in front, and then I minus 1. So I get 1/3 x to the negative 2/3. So I'm going to take that down to make it positive. So I get 1/3 x to the 2/3. And then write it in root form so it's a little easier to see. Cube root of x squared. So here's my f prime of x. Are there any numbers that make this undefined? Well, yeah, if I put a 0 right in there for x, then I'm dividing by 0. This is undefined. So that tells me right there that's a vertical tangent line. Vertical tangent line is any time the derivative is undefined. That's a vertical tangent line. So I'm going to say x equals 0 because it has a vertical tangent line. Okay, so that is everything on non-differentiability. In the last video, we're going to talk about rate of change one more time for today.